easy, and the video's actually really short. So we're going to be talking about converting radians to degrees, and you've already dealt with radians when we talked about the unit circle, so this should be pretty familiar. The very first thing we're going to start with is a formula. All right, easy formula to memorize. To convert radians to degrees, you multiply the radian by 180 over pi. To convert degrees to radians, you multiply the degree by pi over 180. So let's look at an example with these. So we're going to start with this is a radian and this is a degree. So we're going to convert this radian, negative pi over 6, to a degree. So we're going to multiply it by 180 over pi. Now, if you know anything about fractions, you know that I can now cross-cancel the pi's, and I end up with negative 180 over 6, which reduces to negative 30. So negative pi over 6 is negative 30 degrees. Now if we have negative 10 degrees here, and we want to convert this to a radian, I'm going to do negative 10 times pi over 180. And then that's going to give me, once the fraction reduces, will be negative pi over 18. So again, really, really simple. You can use your calculators, but be careful. You need to make sure you leave them in fraction form. So this is your practice. Go ahead and pause the video, do the practice problems, then I'll talk about the solutions. These ones I won't go into too much depth on though. So here are your solutions. Okay, pi over 5 we multiplied by 180 over pi. Again, we cross-canceled, or you just calculated it, and got 36 degrees. Okay, this one 4 pi over 9 times 180 over pi. Again, calculator, and then get 80 degrees. 6 pi times 180 over pi. Again, we put that in a calculator, and we get 1,080. So, all right. The next step is a little bit more complicated. We're going to talk about when we have radians that are not on the unit circle. Now, the ones that we're going to talk about will be unit circle. They all have a corresponding radian on the unit circle. So what we need to do is we need to figure out how can we convert this to a unit circle radian. And we're doing this because in the next lesson we're going to do sine, cosine, and tangent of these. But today all we want to know is let's find the corresponding radian on the unit circle. So it's really, really easy. We just need to find something called the standard position. All right, and it's found by adding or subtracting 2 pi. So we're either going to add or subtract 2 pi until we get, we'll do that multiple times, until we get to a one that's a standard position on the unit circle. And by now you should know what those are. You should be familiar enough to recognize a standard position. So since this one is negative 3 pi over 4, we're going to add 2 pi. If it's negative, you will add. If it's positive, you will subtract. So we're going to add 2 pi to this. So negative 3/4 plus 2 pi. This is not something that you should do on a calculator. If you do it on a calculator, you will not end up with an exact answer. So you need to make sure that you need to be able to do these by hand. So fractions by hand are a little difficult. So we're going to change this 2 pi to 8 pi over 4. And you know when you add fractions, you don't do anything with the denominator. We do just the numerators. So 8 and negative 3 is 5. So we get 5 pi over 4. This is a standard position on the unit circle. And you should know that by now. Now positive, we're going to subtract 2 pi. So we're going to convert this 2 pi to 6 pi over 3. And we end up with 10 pi over 3, which is still not on the unit circle. So we have to do it again. And you may have to do some of these multiple times. So we're going to go minus 6 pi over 3 again. And we get 4 pi over 3, which is one that's on the unit circle. So at that point, we're done. I want you to notice also here that you can skip steps. If you know that 16 pi over 3 is, way bigger than 2 pi, you could do minus 4 pi, or you could do minus 6 pi. You just need to make sure that you don't skip a position. Okay, so, oh, and that was it. There was no practice problem for this one. So I will see you tomorrow.